Space is usually a game of massive distances and comfortable margins. When NASA tracks an asteroid, a close call is often millions of miles wide. But on October 3rd, the comfort zone collapsed. It began with a routine data packet from the Mars Reconnaissance Orbiter. It was supposed to be a standard tracking run for 3IATLAS, an interstellar visitor passing through our solar system. It was projected to miss Mars by a safe, boring distance. But at 2:13 a.m., inside the server rooms of the Harvard Center for Astrophysics, the numbers changed. The margin of error didn't just shrink, it evaporated. The new trajectory placed the comet not millions of miles away, but inside the orbit of Phobos, Mars's innermost moon. In the span of a single update, a harmless flyby turned into a planetary siege. And this time, Earth isn't the target, but we are the witnesses. At Harvard, the initial confusion quickly hardened into dread. The first assumption is always a glitch, a sensor ghost, a bad line of code. Graduate students re-ran the simulations. Then they ran them again. The result was stubborn. Most comets drift through the solar system on predictable arcs, governed by the smooth, unwavering hand of gravity. But 3IATLAS was breaking the rules. The data pouring in from the James Webb Space Telescope in the VLT in Chile revealed a terrifying shift. The comet was threading a needle. The probability models, which usually span vast distances, had collapsed to a corridor barely the width of the continental United States. It wasn't a confirmed hit yet, but the odds were rising with every refresh. By noon, the frantic energy at Harvard spilled over to Pasadena. The data was flashed to NASA's Jet Propulsion Laboratory, the guardians of planetary defense. At JPL, the question wasn't what is it? It was where exactly is it going? To answer that, engineers use a Monte Carlo simulation. Imagine firing a rifle at a target 1,000 times, slightly adjusting for wind, humidity, and hand tremors each time. The result isn't a single line, it's a fan of thousands of possible paths. Usually, 99% of those paths miss the planet, but with 3IATLAS, the fan was drifting dangerously to the left. A cluster of these simulated paths didn't just skim the atmosphere, they terminated on the surface. To make matters worse, 3IATLAS is on a retrograde orbit. It's moving against the flow of traffic in our solar system, approaching Mars head-on at a staggering 54 kilometers per second. At that speed, you don't need a direct hit to cause catastrophe. A glancing blow, or even a close pass that sheds debris, turns the space around Mars into a shotgun blast. Why was the trajectory shifting? Gravity explains most of it, but not all of it. Astronomers noticed a signal in the noise, not a radio transmission, but a physical pulse. Every 17 minutes, with the precision of a metronome, 3IATLAS vents a massive jet of cyanogen and carbon monoxide. This is what scientists call non-gravitational acceleration.
Think of it like a baseball in flight. If the ball had a tiny thruster that fired every few seconds, it could steer itself. That is what 3IATLAS is doing. This clockwork outgassing acts like an engine. It nudges the comet off its predicted path, making long-term forecasting nearly impossible. It's like trying to predict where a car will drive, but the driver keeps tapping the steering wheel every mile. Is it natural? Almost certainly, but the regularity is haunting. And every one of those 17-minute bursts rolls the dice on Mars's future. This triggered a quiet, operational panic. NASA's Planetary Defense Coordination Office is designed to save Earth, but for the first time, they had to pivot their shield to protect machines. Billions of dollars of hardware orbit Mars. The Mars Reconnaissance Orbiter, MAVEN, the European Trace Gas Orbiter, on the ground, the Perseverance and Curiosity rovers. Encrypted orders went out, slew to safety. Imaging schedules were wiped, radar dishes were reoriented. This wasn't a drill, it was a shelter-in-place order for our robotic ambassadors. Because if 3IATLAS hits, it won't be a crater, it will be an execution. Let's look at the worst-case scenario. A direct impact at retrograde speeds releases 2 million megatons of energy. That is not a typo. It is dwarfing the combined nuclear arsenal of every nation on Earth. The blast would excavate a crater 37 miles wide and punch through the Martian crust, but the explosion is just the opening act. Debris would be ejected at escape velocity, tearing through the orbital lanes where our satellites live. The atmosphere, already thin, would be choked with superheated dust, blocking out the sun for years. A Martian nuclear winter. If this happens, the rovers on the ground won't die from the blast. They will freeze to death in the dark, starved of solar power. The search for life, the geology samples, the preparation for human colonization, all of it buried under 10 feet of radioactive dust. As the news spread, the internet asked the obvious question: if Mars takes the hit, does that save Earth? It's a comforting thought. Mars is the bodyguard, but physics is rarely that kind. Mars isn't a shield, it's just in the way. In fact, a high-energy impact could create a halo effect, a cloud of high-speed debris that expands into the inner solar system. While a large fragment hitting Earth is statistically unlikely, the microscopic shotgun spray of ejecta could harass our satellites for decades. This event has forced a psychological shift. For the first time in human history, we're watching a planetary threat unfold, but we aren't the ones in the crosshairs. As of this recording, the coin is still spinning in the air. The fan of probability is narrowing. Most lines show a near miss, a razor-close shave that will be spectacular to watch, but safe for our robots. But the tail of the distribution, the impact scenario, has not disappeared. 3IATLAS is still out there, pulsing every 17 minutes, adjusting its course, teasing the boundaries of our mathematics. We built our planetary defense systems to watch for bullets aimed at us. We never stopped to ask what we'd do if the bullet was aimed at our future home. The countdown continues. We will keep tracking 3IATLAS and update the simulation models. What scares you more? An impact on Earth we can see coming, or an impact on Mars that wipes out our future? Let us know in the comments. And if you want to stay updated on this trajectory, make sure you're subscribed. See you in the next one.